In this video, we're going to examine measures of central tendency. So the common ones are the mode, median, and mean. You can see in this picture here, if we have our data, let's say, as this darker blue line, our mode turns out to be right almost in the middle here. Our median just a little further to the right on this graph, if you will, and the mean a little bit more to the right. Note that the median is the actual true middle value to the data set. Just with this data, there's a little bit more data up on the upper right side. So the middle value is actually right here. And in this data set with a larger spread to it, or a larger variance, the median is still right here, this green line. The mode is way down here, and the mean is way up there. So we'll look at those three measures and we'll examine how to calculate them and which one is best in which situation. Okay, so let's start with the mode. So the mode is the value that occurs the most often. So let's look at these two pictures here. This data set right here has no mode. There are no numbers that occur more than once. Whereas here, there are several values that occur more than once. 5, 2 of those occur. 12, 2 of those occur. The 9, we have 3 of them. That is the mode right there. So there can be no mode, there can be one mode, there can also be several modes. If, let's say, instead here, let's take away, if we were to just take away this top dot here, if we were to say that we did not have that third data value at 9, then 5, 9, and 12 would all be the mode. So let's have a look at this in Excel right now as well. Okay. So let's say these were our data sets, data set 1 and data set 2. And let me just punch them in. Okay, so here we are. This first data set is right here. I just entered it into Excel. So there was a 1, a 3, 2 5s, a 7, 3 9s, a 10, 2 12s, a 13, and a 14. So here they are. Okay, and so you'll notice that 9 occurs the most often. So in Excel, you just type equals mode, highlight your data, and there we go. And the 9 comes out. So those 3 right there, these 9s are the mode. Now, the second data set, this one right here, is this guy. There's a 0, a 1, a 2, 3, a 5, and a 6. So I just punch them into Excel here too. If you type equals mode, see if you can guess what's going to happen. NA. That is okay. There is no mode here. Okay, no mode for this data set, so you get a hashtag NA if there is no mode. Okay. Good. And then finally, this one right here, if you'll notice, there's actually more than one mode. So see, again, if you can spot them by looking at this data here. So here they all are, the 5s, the 9s, and the 12s are all the mode. They all occur the same number of times, they all occur more than once, and they occur the same number of times, so all 3 of them are the mode. Let's try punching this into Excel and see what happens. So it gave us the 5. Let's try hitting enter again. It still gives us the 5. So it just is stopping at the lowest mode. Okay, so it's just giving us the 5. But beware, when we do the mode call, if there's more than one mode, there's not really any way in Excel to find this out. Certainly what you could do, you could first order this data in Excel. So you go to your data tab and you sort it. So you could sort it by smallest to largest. Okay, smallest to largest, you could do that. It's already sorted, by the way. Click OK, and then see which values repeat. You could also do a bunch of other calls. That being said, truly, we don't worry too much about the mode, so I'm not going to go further into how to calculate it if there's more than one mode. Just be mindful of that. Okay, now moving on to something that is a more useful measure of central tendency, the median. So let's have a look at this guy here. Okay, so median is the middle number, if you will. So the median has the strength, if you will, to it, that it doesn't get skewed. So the mean is sensitive to extreme values. If there are very large values or very small values in your data set, the mean gets affected by them, whereas the median doesn't. So you can see in this picture right here, see this very large value here for 20. It's just the same as if the value was 15, if that makes sense. So this data set and that data set have the same median. So this guy and this guy are the same. Doesn't matter if there's a very large value, it literally goes and finds the middle value, if you will. Okay, now to get that middle position, you do n plus 1 over 2. There are actually several ways of getting the median as well, depending where you read. So this is just one way. They all give you values that are very similar though. And again, this is just an approximation to your, usually you get your median to approximate your value of your data set in general if you were to forecast a future data value. So it's all a rough approximation. So there are different methods other than this one to get your median. They all come very close. They're all just as good. But for us, for our course, here's what we're going to do. We are going to use this formula where we take n plus 1 over 2, where n is our number of data values. So it's the size of our data set. And then if the number of values is odd, the median is in the middle. If the number of values is even, the median is the average of the two middle numbers. So let's have a look again at our data sets right here. These guys right here. Okay. So let's go figure out how many data there are in each one. Okay. I'll hit pause here while I set. Okay, so first of all, to get the size of the data, you could literally just count it, have a look at it quick, probably count it in your brain. But if you want to count it here, it's just equals count. Okay, and same for the next one. Okay, this one's going to be 13 if this one was 14. And here, this guy is going to be 6. Okay, so the first and the second, or data set 1 and data set 2, both have an even number of values. Data set 1b here has an odd number. This one has 14, so this one has 13. So how do we go about finding the median now? So let's go find that median. Okay, so let's first look at data set 1b. So again, this data is already ordered. So we can just go look for the middle data value, or if you will, we know that there are 13 data in this data set since there's 14 in this one. This one's one smaller. So let's just try the 13 plus 1 divided by 2. So n plus 1 over 2 gives us position 7. So we can literally go count 1, 2, 3, 4, 5, 6, 7. And here we are. So in data set 1b, the median is at this 9 right here. Or, much easier than that, and this is what I definitely recommend, just do the equals median call in Excel. Okay, now let's examine data set 1 here. So let's have a look at how we would get the median for this data set. Because it's even, it's going to be a little bit different. So let's redo our formula n plus 1 over 2, where n is now 14. There are 14 data here. So we get 7.5. So if we count down 1, 2, 3, 4, 5, 6, 7.5, well, what that means, we're going to average the 7th and the 8th data values. So if our data set has an even number of data, then we average the two middle numbers, so the 9 and the 9. So those are kind of technically the median. Now, much quicker than that, especially with large data sets, just have Excel do it for you, equals median. And beautiful, the 9 also gets returned. Same here, if we were to find the middle value, n plus 1 over 2 is 3.5. We average data as numbers 3 and 4, which are the 2 and the 3. Guess what that gives us if we just do Excel's median call? Just 2.5, the average of these two. Okay, moving on to our next measure of central tendency, which is the mean, and that's the last one. And in Excel, we're just going to do an equals average call, but let's have a look at the formula just once here. We're going to have to do manual formulas similar to this in the future, where there are no Excel calls, but we won't have to do it for this one, for the average. But let's just have a look at it. So let's have a look at this symbol right here. This means to sum. So this is the summation notation, sum up all of the x values. So xi means any of the x values. So do that from 1 all the way till n, where n is the size of our sample, or how many data there are. So sum them all up, divide by how many there are. Okay, and that will give us our average. So let's try that out in Excel. So let's say we wanted to do that for these guys here. Okay, so let's try this formula for the first data set. So what we can do in Excel, we can just sum up all of the data here. So the Excel sum call will sum up all of those data values, go highlight them all, and divide by how many there are. So you can either just divide by the 14, which is n, or your sample size, or if you'd like, this is one of my favorite Excel calls for stats. It's the count call. So you can go count how many data there are as well. And that gives you 8.07. Now, much better than that, though, is just to do an average call. Okay, so just do equals average, go highlight all of your data, hit enter. And same for all of them. Average these guys, and average these data values. So again, it's nice to have a look at these symbols. We will need to use them later, let's say for what's called the root mean squared error, for decision analysis, getting some of our standard deviation values, etc., etc. But for now, just starting out, just use your equals average call for your mean. Use your equals median call for your median, and use your equals mode call for your mode. Now, one final thing to wrap up in this first part of your first lecture here is to talk about which one should we choose. So the mean is generally used unless there are extreme values. So if you have extreme values, like very high values or very low values, you're better to use the median. If you have a very large data set as well, and there just might be extreme values, use that median. People don't use it often enough to describe the middle value of their data set. Now the mode is basically almost never used. So out of the three, usually I choose the median for large data. Unless I know that there's not really any extreme values, then you can use that mean. And that concludes your first lecture in central tendency measures.